My name is K. Sai Chauhan from IT B section. Now I am going to explain about the topic named Object Oriented Modeling and Control. First, introduction to Object Oriented Modeling. Object Oriented Modeling, known as OOM, is a programming paradigm centered around the concept of objects. Objects combine data and behavior, representing real-world entities in a structured manner. Object-oriented modeling enhances software design by promoting reusability, modularity, and scalability. And the main attributes of object-oriented programming are inheritance, encapsulation, abstraction, polymorphism. Then, key concepts of object orientation. The primary concepts of object orientation includes classes, objects, inheritance, and polymorphism. A class defines the properties and behaviors of objects serving as a blueprint, which also known as a class is the blueprint of the objects and the behaviors. Inheritance allows new classes to inherit attributes and methods from existing classes, promoting code reuse, which means a superclass can be inherited by their subclasses. The role of classes and objects. Classes encapsulate data attributes and methods that operate on the data. When a class is instantiated, it creates an object, which is an instance of that class. Objects interact with one another through defined interfaces reflecting real-world interactions, like classes and objects in C++, which means there is a class, main class, and the main class can be divided into three subclasses. Then, inheritance in object-oriented modeling. The inheritance in object-oriented modeling and object-oriented programming are same. Inheritance supports hierarchical class structures, allowing for shared behaviors among classes. A subclass inherits from a superclass, which can lead to more specialized functionality. This promotes code reuse and simplifies maintenance by centralizing common behavior. Like base class can be divided into class 1, class 2, and class 3. But the three of derived class have the same attributes of the base class. Then polymorphism. Polymorphism allows methods to perform differently based on the object invoking them. It enables a single interface to represent different underlying data types. This enhances flexibility and the ability to extend systems without modifying existing code. In polymorphism, we divide a code into different parts and proceed from part to part, which is very easy to make the code successful. Object relationships. In object-oriented modeling, the object should be related to another object through associations, aggregations, and composition. Associations represent a general relationship between objects, while aggregations imply a whole part relationship. Compositions indicate a stronger relationship where the part cannot exist independently of the whole. Designing object-oriented systems. Effective object-oriented modeling requires careful planning and analysis of system requirements. The Unified Modeling Language UML is commonly used to visualize object-oriented designs. Design patterns can provide reusable solutions to common problems in software design. Object-oriented control systems. Object-oriented control systems apply object-oriented modeling principles to manage and control system behavior. They encapsulate control logic within objects, making systems easier to manage and extend. This approach allows for better integration of control strategies and system components. Then, benefits of object oriented control. Object oriented control encourages modularity, making it easier to develop and test individual components. It supports dynamic behavior, allowing systems to adapt to changing conditions at runtime. The encapsulation of control logic improves system reliability and reduces complexity. Encapsulation means making the code into smaller pieces and developing a better structure of the code and reduces complexity. There are challenges in object oriented modeling. Object oriented modeling can introduce complexity if not managed properly, especially in large systems. Developers may struggle with over engineering solutions, leading to unnecessary abstractions. Ensuring performance and efficiency can be challenging as layers of abstraction increase. Object oriented modeling uses object orientation as a basics of modeling. Models a system as a set of objects that interact with each other. No semantic gap or impedance mismatch. Seamless development process. There are tools for object oriented modeling. Various tools support object oriented modeling, including UML tools and integrated development environments. Popular UML tools include Lucidchart, Visual and Paradig, and Enterprise Architect. IDEs like Eclipse and IntelliJ IDEA provide features that facilitate object-oriented design and development. Case studies in object-oriented modeling and control. Numerous industries have successfully implemented object-oriented modeling principles in their control systems. In automotive engineering, object-oriented modeling allows for the development of complex vehicle control software. Industrial automation system benefit from object-oriented modeling by improving the modularity of control strategies. Then, summary of object-oriented modeling and control. Object-oriented modeling provides a framework for designing complex systems with real-world counterparts. Control systems that leverage object-oriented modeling principles are more adaptable, maintainable, and reusable. Understanding object-oriented modeling is essential for modern software development and systems engineering. And object-oriented programming concepts are class, objects, inheritance, encapsulation, abstraction, aggregation, compositions, association. Thank you. Here, the main part of the object-oriented control system is encapsulation. Encapsulation is very useful for the control over the logic within objects. By controlling the logic within objects, it makes us easier to manage and extend the code or the program. And polymorphism, it is also plays an important role in the object-oriented control system. It allows you to approach the code step by step and by small parts, which is very useful for the reducing of complexity and very helpful for reducing the errors in the program. And abstraction is also plays an important role in object-oriented control system. These three are very important for the object-oriented control system. Thank you. Then, benefits of object-oriented control. Object-oriented control encourages modularity, which means the time of the code without the errors, or reusability, which means a code can be reused by the subclasses how many times or n times the subclasses want, with same the attributes of the superclass and the behaviors, all the attributes would be same for the subclass. Thank you.